To understand the phase space, it is important, first of all, to understand what is pressure volume space. And notice it carefully, please, what the x-axis represents and what the y-axis represents. And take PV diagram for example, each point on the diagram is a pair of pressure and volume. And each point describes the gas system at a particular moment. If somehow you change, compress or expand the system state, okay, that is pressure and volume will change. Then the point will move to another location in the PV space is what natural. Now to understand again the phase space, imagine a particle in three-dimensional space. And again imagine that you set up a Cartesian coordinate system x, y, z. Then at any instant, at any time, the position of the particle will be described by the triple of the number like x, y, z. This carries the information of the configuration of the system. That is where the particle is. The space of all such triples is called the configuration space. But just the position does not completely characterize the state of the particle. There is also the state of motion. The state of motion is well described by the momentum. Momentum is a vector quantity. And the triples of the numbers like px, py, pz, which for a particle in the three dimensions with mass m is like that. Px is m into vx, py is m into vy, and pz is m into vz. These are the momentum values along x, y, z. Okay. And vx, vy, vz, the velocity vectors of the particle. Now in vector notation, we have p vector is m into v vector. The p vector is a measures the quantity of motion associated to a particle which is having a velocity v. Also in the vector notation, the position x, y, z can be written as with r vector, R vector is what? I cap x, j cap y, and k cap z. And p vector is written as p vector is I cap px plus j cap py plus k cap pz. Now when the time is fixed, the particle is somewhere with some momentum at a particular time when the time is fixed. And then thus it is described by a pair r vector and p vector. Think. All these pair, form the phase space, and may you call it with any symbol like capital M or any other symbol. Okay. Now that the it turns out that as the time passes, the position varies in time, and this can be described by an association like t. It gives you that at any time t, r becomes a function of t. Okay, that is r and r in a t is the position triples at a time t. The same happens for the momentum at any time. At any time, the momentum also becomes a function of time. This is by definition of the sequence of the points of the phase space, and the phase space. Now when we integrate the component of the position, we get the volume. When we sum up when we integrate the components of the position, we get the volume. And if we integrate the components of the momentum, we get the momentum volume. And if we integrate the both, then we get the phase volume. Now, in phase space represents the state of the whole system. For example, if you have a system of n particles with coordinates r1 vector, r2 vector up to rn vector, and momenta like p1 vector, p2 vector, and up to pn vector, then the general state of the system I'm talking now will be a point in the 6 n-dimensional phase space. So it is a point in the 6 n-dimensional phase space, because we are familiar about the 3-dimensional space and 6-dimensional phase space, and moreover 6n n particles are there. That will be also a point in the 6 n-dimensional phase space, and that point represents to r1 vector, r2 vector, and up to rn vector, p1 vector, p2 vector, up to pn vector. So to represent a state of the whole system, we are having a point in the phase space which is 6n dimensional. So it is very difficult, to imagine such a phase space, and we cannot throw this type of phase space on the paper because it's very difficult, because the paper is two-dimensional space. Okay, but remember, the phase space is a coordinate and momenta space combined, and 6n dimensional, and the system is like a point which is at there. If the system property changes, then that point will move to somewhere other place in the 6n dimensional space. Okay, thank you.